All right, so here we are with the inverses of linear and rational functions assignment. So I thought I would just help with this assignment. I think it's good sometimes to go over the work. In order to find the inverse of, in this case, a linear function, meaning that this if graph is a straight line, the first thing we have to do is rewrite this without the function notation. And so instead of writing f of x, we're going to use y. So we'll write y, okay, and then equals. We're going to go ahead and drop this vertical line here just to keep our work straight. Negative 1/2 x plus 9. Okay, so the trick with inverses is to, when you get it like this where you have y equals, you just swap the x and the y and then solve for y. Okay, so the first part's easy. Just swap the x and the y. Everywhere you see an x, put a y. Everywhere you see a y, put an x. Okay, so we'll do that here. So now we're going to say x equals negative 1/2 and then y plus 9. Okay. All right, you're almost home. So now the goal, pardon me, is to get y by itself, preferably on the left side. Okay? So I have a minus sign here, so I can do the inverse operation of subtraction by adding 1/2 y to both sides. And when I add it to the right side, you see that the negative and the positive, they cancel out, so that just goes away. And I've essentially moved it over to the left side. And so I'm going to put plus 1/2 y. And then when we rewrite all this, it'll be 1/2 y plus x, right, because this is a positive number, equals the only thing remaining on the right, which is a 9. And that's what we're going to do now. So we have this 1/2 y, okay, plus x equals 9. All right, now remember, we're trying to isolate the y variable all by itself, so perhaps I should subtract x from both sides. So doing that opposite of addition is subtraction lets me cancel that out over here, and then I also do minus x over here. Okay. Now when I rewrite this, I'm going to write 1/2 y equals, but then I'm going to move this x term up front because the variable terms always lead. These constant terms go at the end. Okay? It doesn't make any difference, but it's a stylistic thing that they... So we have 1/2 y equals negative, and here I'm going to do something. I'm going to throw in, instead of writing negative x, I'm going to write negative 1x, because that's really what negative x means, and it might help us in a minute. Okay, and don't forget the 9 plus 9. Okay, so now all I have to do is get rid of this 1/2. Okay, well, to make it cancel, I'd need to multiply by the reciprocal of 1 over 2, which is 2 over 1. Okay, so we'll multiply both sides by 2 over 1. On the left side, I need to multiply by the fraction 2 over 1 since I have a fraction here. And that allows me to cancel these 2's, which successfully isolates y by itself because the ones can't, the ones don't matter. And so y is alone on the left side now. Okay. Now on the right side, since I have to mirror this transaction, I need to encapsulate everything on the right in parentheses and then multiply by 2. Okay, so there's my multiplication symbol, and then I'm going to multiply by 2. And now we have to distribute. Usually when we do distributive property, the 2 would go up front, but the way that we write the problem, the 2 ended up over here. It's okay, we can do reverse. It's the same thing. We're going to multiply 2 times negative 1. Okay, and we're also going to multiply 2 times, I said negative 1x, and 2 times 9. Okay, all right, so we have y by itself. Y equals, and then 2 times negative 1x is negative 2x. So we'll write negative 2x. And then 2 times 9 is 18, positive 18 plus 18. Okay, you're successful. And so what you should do is, this is actually the inverse equation. So you can write y to the negative 1. Okay, that negative 1 exponent is how we refer to the inverse. That's the notation style. The final step is to put this back into this function notation, but we're going to use the inverse function notation, which just means I'm going to put that negative 1 there, right there between the f and the parentheses. So let's go down here and just swap out that y for this function notation. So it's f inverse, again that's that negative 1 exponent of x, so there's my f of x notation, equals negative 2x plus 18. And ladies and gentlemen, that is the solution. So that's what we wanted. Let's put that in a box. But I thought what I would do is show you what you accomplished. Okay, so what is the kind of bigger question is, so what? Like, what's the relationship between the original function up here, which I'll put here in green. This was the original function. Like, what can we learn visually if we were to graph both the function we were given and its inverse? All right, so if you give me a moment, I'm going to switch. You're going to see my recording setup here for a second. And now what I've done is here in Desmos, this great calculator, I've already put in the original equation. Okay, so we can't write function notation in Desmos. We have to put y equals. Now I'm going to type in, y equals negative 2x plus 18. And I just thought it would be interesting to show. So the red was the original, and the blue is the inverse. And I think it's very interesting to note that that they intersect there at 6, 6. So we're not going that far. We're not analyzing anything else, but let's just see what else we got here. So there's our y-intercept for our inverse function. There's the x-intercept for the inverse function. Let's check the y-intercept for the original function. Okay. So I'm just going to try to point some things out. And look over here. Oh. Are you noticing any overlaps? Like, no, look at it. It's weird, right? So the original function is the red one. So it has a y-intercept of 9. The inverse function has an x-intercept of 9. The original function has an x-intercept of 18. The inverse function has a y-intercept of 18. Isn't that interesting? So I thought that we would make a note of that, and that's pretty cool. So I think we'll save this graph, okay? And then whenever you want to look at that again, just keep that in mind. Like that's what inverses are about. You notice there were a lot of similarities there. Everything kind of just flipped, changed in a weird way. X-intercept became y-intercept, and such as, and so forth, and like such as, okay? All right, so let me get back to, let me scene transition here back to the camera. Okay, so I don't want to make this into a 1,000-hour video, but I really did want to show, let me add some more light to our situation here. I really did want to show that. I think that's kind of like a big aha moment. Okay, so here is our next one, number 2. Now, right away, whenever I see, this is called, we use the term naked variable because there's no number there. I think it's always useful to put a 1 because that is, in fact, what's there. So it's negative 1x minus 16. Okay, so let's move on. So the very first step is to go ahead and write this in terms of y. Y equals negative 1x, okay, minus 16. This should be, I think, a little simpler of a problem. So now our process tells us to switch x and y. Okay, so x equals negative 1 y minus 16. And now we're going to solve for y. Again, get y by itself. Okay. So, my first step would be to add 1y to both sides. Okay. And of course, 1y is just y, all right? When it becomes convenient to do so, we'll simply drop the 1. And I think we've probably reached that point. So now when I write this, I'm going to just write y plus x equals negative 16. And I've intentionally left some space here, okay? Because now I'm going to go ahead and reverse that plus x and subtract x from both sides. Okay. and it'll fit nicely in there. Okay? So then we'll write we actually cancel these out. So now we have y by itself y equals, and then negative x minus 16. Now, do you notice something interesting about this one? The inverse, so this is the inverse. The inverse is the same as the original. Interesting. Okay? So the f of x notation, there would be f inverse x and we're not going, it's not here that we're going to get into the implications of, okay, what does it mean when a function and its inverse are identical? That's a higher level topic that we're not here to do. We're really here learning the mechanics of doing this. Okay. Okay, so put that in a box. All right, so now we'll move on to number 3. Find the inverse function in slope-intercept form. Okay, yeah, I mean, we're just going to repeat this process. First we write, here, let me drop this vertical line here. I use the vertical line to keep the equals signs lined up and make everything look pretty. So now we're going to drop the f of x and use y. I'm going to try to write a little smaller here because I think we're going to have a little bit of work to do. I'll zoom in a little bit more for you. Okay, so y equals 2/5 x plus 4. Okay, so now remember, swap the x and the y and solve for y. So first we swap the x and the y, so x equals 2/5 y plus 4. And now we solve for y, okay? So right away, I like to move y over to the right side, to the right side, to the left side, to the correct side. So I'm going to subtract 2/5 y. This is a bit cumbersome to write down, but you got to do it. Okay, so that'll cancel that out right there. And then we'll come over here and we'll subtract 2/5 y as well. All right, and when we clean this up, it's going to say negative 2/5 y plus x equals 4. All right, so negative 2/5 y plus x equals 4. Okay. You might notice me swapping sometimes between this horizontal fraction bar and this diagonal fraction bar, and I'm really doing that just to remind the viewer that it doesn't matter. Okay, so now we're going to get rid of this x by moving it to the right side. So I'm going to subtract x from both sides. Okay, what does that really look like? Well, this just cancels out. Yeah. So all I've got over here is negative 2/5 y. We'll go ahead and write that. Negative 2. And this time, because I know what I'm going to do next, is I'm going to have to multiply by the reciprocal of negative 2/5. I'm going to put it in that horizontal line fraction format. Negative 2/5 y equals, and remember, lead with the x, equals negative x and then plus 4. Okay. Well, now, what have I got to do over here to get rid of this negative 2/5? Well, I got to multiply by the reciprocal. Right? I got to multiply by negative 5/2. Negative 5/2. And then does that all cancel out? Cancel, 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 cancel. Okay, great. So now y is by itself. Fantastic. Now on the right side, I've got to put this entire expression in a boundary, okay, in a box sort of thing, and then multiply by negative 5/2. Okay, so we're going to multiply that expression by negative 5/2. And there's going to be a distribution, okay? So what is the distribution? Well, we're going to take this entire negative 5/2, and we're just going to distribute it down here, okay? It would be good at this point to put a negative 1 there, to just show that that 1 there in front of the x, negative 1, and also distribute, multiply to the 4. Okay? So let's keep rolling along. We got y equals, now a negative times a negative is a positive, so negative 5/2 times negative 1x is going to be negative 5x, pardon me, it's going to be positive 5x/2, or positive 5/2 x. And if we're writing this in slope-intercept form, we want the fraction out in the front. So we're going to put 5/2 x. So, you know, rise over run. The rise is 5, the run is 2. Okay. And then we're going to multiply negative 5/2 times 4. But one thing I can do to make this a little bit simpler is cancel this 4 with this 2 and make this a 2 and make this a 1. Okay, so my life is a little bit simpler now. I'm just multiplying negative 5 times 2, which is negative 10, right? So now I know my y-intercept is negative 10. Here's minus 10. Okay? So that is your inverse equation. And now let's make it an inverse function by bringing back this f inverse x equals 5/2 x minus 10. I think this would be let's put this in a red box. And I'm going to do a little magic here with the recording software to show you what it looks like when these two look like graphed without wasting the time of having you watch me set it all up. So I'll be right back. Okay, so here what I've got graphed in red is the original function, okay? And notice the x-intercept is at negative 10 comma 0. The y-intercept of the original is at 0 comma 4. Now, look at the inverse function. The y-intercept is at 0 comma negative 10. You see, the x-intercept of the original is at negative 10 comma 0. The y-intercept of the inverse is at 0 comma negative 10. Very interesting. And look at the x-int of the inverse. It's at 4 comma 0. That corresponds to the y-intercept of the original, which is at 0 comma 4. Do you see what's going on here? Things are just getting switched around. And then the intersection is at 20/3 or 6 2/3. So that's 6.6666666 repeating, comma 6.6666666 repeating. Very interesting behavior, functions and their inverses. Okay, so I thought that would be elucidating to see how these things are, like, what's going on, and it's kind of a mystery, right? Because we haven't really explained the theory. We're just computing things, but I wanted to show the graph. I won't be doing this for every single problem, but when it's interesting, I think I'll show it. So now we'll take another break as I get back to the screen that shows the document camera. Okay, and so we're back on the document camera. We're finished with number three, and we're moving on to number 4. Okay, so here we are up here. So same exact directions. We're going to find the inverse of the function. And, I start with my straight edge and draw this vertical line so that everything is neat and tidy. All right, so what's our first step? Replace f of x with y. All right, so we're going to just write y equals negative 1/3 x plus 1. Okay, and so now my next step is to swap the x and the y. Okay, so x equals negative 1/3 y plus 1. Okay, and now I want to get this y over on the left side, so I'm going to add 1/3 y to both sides. And here I'm back to using that diagonal there, trying to save a little space. We'll add 1/3 y to both sides. And I will cancel out on the right because you have negative and plus, okay? So now when I rewrite this, I'll drop the plus symbol and just lead with the 1/3 y plus x equals 1, okay? And so we'll go back to writing the fraction properly. 1/3 y plus x equals 1. Okay? So now what do? Right? I want to get rid of the x, right? So I'm going to subtract x since it's being added, so minus x on both sides. And I can cancel those x's out now. When I rewrite this, I'll lead with the negative x, and I'll put negative x plus 1 on the right, and I'll lead with 1/3 y. That'll be the only thing on the left. So here we have 1/3 y equals negative 1x. Again, you'll see me do this from time to time where the naked variable is fine in some cases. In other cases, it's helpful to have the 1 there to remind you that you are, in fact, multiplying negative 1 times x. Okay? So negative 1x plus 1. You can always just drop that 1 in if it's ever convenient. And sometimes it is. Okay, so now how do I clear this 1/3? Well, I'm going to multiply by the reciprocal on both sides. So multiply by 3 over 1. And was that helpful? Sure, because it allows me to cancel the 3's. And the 1's don't matter, so y is effectively by itself now. So we can write y equals. And remember, at this point, it's no longer y equals, it's y inverse. So that's y to the negative 1 power, if you want to think of it that way, equals. And then we have to encapsulate this whole expression, okay? Because we're going to multiply by 3. All right, so we don't need to multiply by 3 over 1 because there's no fractions on the right side. We're just going to multiply by 3. Okay, and now I'm going to do the distributive property, and I'm going to multiply that 3 to that negative 1x, and also to the 1, okay? So the inverse y is going to be 3 times negative 1x is negative 3x. Three times 1 is 3, so negative 3x plus 3. And so now the last step is to just put it back in function notation. So inverse function notation would look like this. F inverse x, so f to the negative 1 of x equals, and then negative 3x plus 3. Okay, and that's the thing that you would put in the red box because that's what they wanted. It's in slope-intercept form, mx plus b. All right. And we'll take a quick break here and see what that looks like graphed. Okay, so here we are looking at number 4. The red line is the original graph, and the blue line is the inverse. So again, we see this intersection has these identical coordinates, 0.75, 0.75, very interesting. So the y-intercept of the original function, 0, 1, corresponds to the x-intercept of the inverse function, 1, 0. And the y-intercept of the inverse function, 0, 3, corresponds to the x-intercept of the original function, 3, 0. And so you see, once again, this behavior of swapping values around. It's pretty interesting, isn't it? That's what we're doing when we're taking the inverse. I always think it's good to visualize what you're doing and see what's going on. It's pretty cool stuff. And there's actually a lot more to this, we're stepping into the shallow end of the pool, and this is actually if you're sort of glancing at this and just noticing that there's this weird correspondence. If I swap the digits there of the coordinates, if I swap the x and the y of the y-intercept, it becomes the x-intercept of the inverse. It's very interesting. Okay. All right, we're going to head back to the paper now. Okay, so we're going to move on to number 5. And I don't think we need to see any more graphs. I think you kind of got the idea. All right. And this one looks fairly straightforward, right? The absence of fractions is always a good thing. So here we have y equals, so I should have said that's the first step, is to write f of x, get rid of that, write y. And then x plus 16. And then we got to swap the x and the y. So x equals y plus 16. And now we solve for y. And this time I'm going to break my own rule, because there's a one-step solution here if I solve for y on the right. Just subtract 16 from both sides. And then we can use a property of math called the reflection property of equality that will allow me to write it however I want. So I'm going to write x minus 16 equals y inverse. Okay, that's totally legal to do. And then I can just reflect that and make it the way I want it to look, which is to have y over here. So I can write y inverse equals x minus 16. I hope that's clear. Like you're allowed to do that. X minus 16. Okay, so now we've got it written right. So now we just have to switch out that y for the f of x. So f inverse x is like this. You got your f, and then it's inverse of x. Okay, kind of a complicated notation. Equals x minus 16. Notice the difference between the two. So you had the original function was x plus 16, and the inverse this time is x minus 16. So let's think about that for a minute. They have the same slope, so they're parallel lines. The inverse function here is a parallel line, but its y-intercept is 32 boxes below the original, right? Because it's plus 16 all the way down to minus 16. That's a total of 32 space. Very interesting. So these are parallel lines. Same slope means parallel lines. Same slope, different y-intercept, parallel lines. Okay. So very interesting. And we will put that in a box. And move on to number 6. Find the inverse function in slope-intercept form. Okay. Once again, same exact thing that we were asked to do before. I see a fraction, so I'm drawing a long line. My first step is to go ahead and write this as y equals. So y equals 1/2 x minus 15. And now I'm going to swap the x and the y. So now x equals 1/2 y minus 15. And then I'm going to solve for y. And I'm going to go ahead and just move this negative. So I'm going to move the 1/2 y over. All right, and that allows me to cancel out here. All right, bye-bye. And so now I have negative 1/2 y plus x equals negative 15. Negative 1/2 y plus x equals negative 15. Okay, so that's where your problem should be. Now you're going to get rid of this x by subtracting x from both sides. Minus x, and this cancels. So we just have negative 1/2 y on the left side equals negative x minus 15. Okay, we already know what's going to happen, right? We're going to multiply by the reciprocal, and then we're going to have to put this in parentheses and then do the distributive property. Okay, it's very much a mechanical process that we do. Okay, so this allows me to cancel everything out over here, and then on the right side I just multiply by negative 2. Okay, so that's where it would help to put this 1 here. So you know, like, okay, negative 2 times negative 1 is positive 2 and whatnot. So we're going to write y. At this point, I think we're in a good position to write y inverse is equal to a negative times a negative, a positive is going to be 2x plus 30. Okay, because negative 15, negative 2 plus 30. Okay, final step, rewrite in function form. So f inverse of x is equal to 2x plus 30. And that's what we're going to put in the box. Now that you've seen a few of those graphs, like, you can almost imagine that this is going to have those same properties. Look at the originals. 1/2 x minus 15. And then the inverse is 2x plus 30. There's some relationship there between those numbers, right? 1/2 becoming 2 and negative 15 becoming 30. I think you see where this is going. All right. You know where else this is going is to number 7. Now, for number 7, things they appear anyway, to get a little bit more complicated. Because, for one thing, we got a fraction and there's 2 x's this time. So does that change anything? I mean, what goes on? You know, like, how does that work and whatnot? Actually, it's just the same process. So we'll walk through it and I'll show you how easy it really is. Okay? Okay, so here we go. Yeah, don't let this frighten you at all. Just draw a long line because the mechanics can get a little tricky. So here we go. We're going to start by writing y equals, and I like this part because now I get to kind of make this fraction look a little bit bigger. So we got negative 4x over 2x minus 3. Okay. Now we do the same thing we did before. Swap the x and the y. So everywhere I see a y, I'm going to put an x. Everywhere I see an x, I'm going to put a y. Okay, so x equals, and that would be negative 4y over 2y minus 3. Let me zoom out a little bit, I think. Yeah. Okay, so now what's the goal? The goal is to get y by itself on the right side, left side. Okay? Well, what would be your sort of opening chess move here? Well, here's what I'm going to suggest. Let's group this and multiply it over here. And then multiply it over here as well. So I'm creating the framework. You see that? So what do you think I'm going to put in those open parentheses there? Well, I'm just going to put 2y minus 3. 2y minus 3. Okay? And the beauty is I can just cancel the 2y minus 3 on the right side. And I don't have to distribute that x. I can leave that just like it is if I want to. It's totally permissible. So here's what I'm going to write. I'm going to keep this parenthetically trapped and do 2y minus 3. I'm going to keep that multiplication symbol there to show that I can't just ditch the x. I'd have to divide out the x to get rid of it. So now I've got equals negative 4y. Okay, now what? Well, we should divide out the x, right? We should get rid of the x. So let's divide out the x. We're going to divide both sides by x. And that allows me to say bye-bye to the x on the left side. And now it's in the denominator position over there. So we can get rid of the parentheses now. We can just write 2y minus 3 equals negative 4y over x. Like that. Okay, so now how do I get what should I do next? Okay. Well, I tell you what, I definitely think what I should do next is sort of take this and sort of multiply by 1 over that thing, right? So you see what I'm doing here? I'm going to multiply by 1 over that. And that'll allow me to get rid of it on the right side. So I'll have negative 4y. And now be careful here, because when you go over here to this side, you have to multiply by 1 over negative 4y. So just be very careful. So I think it would be useful to go back into the parentheses here as I'm about to multiply by negative 4y. But if you notice what I'm really doing, right, is I'm really just dividing by negative 4y. Okay, so now on the right, what has happened? Well, these canceled out. The x is in the denominator. There's a 1 in the numerator. So before we even mess with this at all, let's just rewrite it. 2y minus 3 over negative 4y is equal to 1 over x. Sorry, couldn't see that. Okay. Okay, so now what we have here is a proportion. And we're essentially going to do the butterfly method. That butterfly method is like this. So we cross multiply and divide, sort of. Okay? So that's what we're going to do. So we're going to say 2y minus 3 is going to be in parentheses, and then we're going to distribute that x. We're going to multiply that by x, and then have negative 4y times 1. Okay, so let's just go ahead. Let's start with this harder looking one. So we'll have x times 2y minus 3 equals pardon me, negative 4y. Okay, so now we have to distribute the x. And so we're going to end up with 2xy minus 3x equals negative 4y. Okay, and what we can do now is, well, there's a lot of things we can do now. Okay, so now what we're going to do is, pardon me, we're going to add 4y to both sides of the equation here. So that the right side is just 0. Okay. And that will cancel here. And now we'll have 2xy minus 3x plus 4y equals 0. All right, and now I'm going to start moving my x's to the right side by adding 3x to both sides. Okay, and that will cancel out this 3x here. And so now I'll have 2xy plus 4y equals 3x. Okay? And now what I'm going to do is notice that my greatest common factor in 2xy and 4y is actually 2y. Okay? So I'm going to essentially, let me show you here with the pencil. I'm going to divide out of each of these terms 2y. This is kind of like reverse distribution. Okay, so those in that 2y, that's going to move out here. Okay, so that'll be 2y out here, and I will have canceled the 2 and the y, and this term right here will just be 2y. Okay, when we're done, so it's going to be 2y, and then inside I'll have an x by itself plus 2y, and then over here 3x. Okay, so I'm going to run out of room here, but I'll write that final line here. So we have 2y and then in the parenthetical expression, I've simplified it down to be x plus 2y. All right, and then on the right side, I have equals 3x. And we're out of room, so I'm going to have to use this white space here. Okay, so let me set that up. I'm sorry, I made a small mistake here. So when I when I divided 4y by 2y, I actually canceled the y's out. So this is not a y, it's just x plus 2. Okay. All right, we're really close to being done. I just have to divide both sides by x plus 2 and then get rid of the 2 in front of the y, and we'll be good to go. So what I'm going to do is I'm going to move this problem over here. Okay, and we're going to kind of rotate the paper a little bit. And let me rewrite the problem just so we can see it. We have 2y, open parentheses, x plus 2. Okay, and that equals 3x. All right, so, I mean, this is, now we can just divide both sides by x plus 2 in parentheses. So we'll go ahead and divide out x plus 2. X plus 2. And see, over on the left side, I just got rid of the x's because they cancel. And now I've got 2y. Let me make a new line here. I got 2y equals 3x over x plus 2 in parentheses there. Okay, final step. Final step is to divide both sides by 2. But since I've got a fraction over here, I'm gonna actually, division is the same thing as multiplying. If I want to divide by 2, I can do the exact same thing by multiplying by 1 over 2. Does that make sense? That's the same thing as division. And it's going to help me because over here on the right, I've got a fraction and I want to multiply by 1 over 2. Okay, so the beauty of that is that I cancel the 2's and I finally got y by itself. Okay, so this is now the y inverse equals, okay, and now we're going to just distribute the 2 here. So it's going to be 2x plus 4. You see how that's going to work? Now, is there a smarter way to do that? No, we're just going to do it this way. So we have 3x on top, and then down on the bottom, I've got, because I'm distributing the 2 to the x and the 2 to the 2, right? So I'm going to have 2x plus 4. And my final function notation would be f inverse x equals, and then here I'm going to run out of space again. So I'm going to say f inverse x equals this, and we're going to draw a little arrow to indicate what it equals. We're going to have to, it's like the reader is taking a little journey. Okay, it's like, look here, please. So f inverse x is going to equal, why don't we just write it again? F inverse x equals 3x over 2x plus 4. Okay, my goodness, that was the algebra involved was kind of crazy, huh? Okay, so we can put a red box around that. And I think this would definitely be a fun one to graph, since we work so hard. Okay, so give me a second, I'll set the graph up. Okay, take a look at this. So the red graph is the original, and the blue graph is the inverse. So just look at that. Look at that strange behavior there. Notice they intersect at 0, 0. Where else do they intersect? Negative 0.5. Very interesting. Look at that. Unusual looking curves, huh? All right, well, that is number 7. And let me get set up back to the problem set. Okay, here we are with number 8. So f of x equals 7 over 7 minus 5x. All right, so the step 1 is to draw this line. And then step 2 is to write y equals 7 over 7 minus 5x. Okay, now let's replace the x and the y. So x equals 7 over 7 minus 5y. And let's solve for y. Same idea as before. We're going to multiply this 5y out here and here. Okay, so I'm going to say 7 minus 5y here. And 7 minus 5y here. Okay. And that cancels these out. So here's what our problem looks like now. I'm going to move this x over here. I have x, open parentheses, and then I'm going to rearrange these terms a little bit. I'm going to say negative 5y plus 7. Doesn't change anything to rearrange the terms like that. Equals 7. Okay. Well, I think what we should do is we'll divide both sides by x. So that we get the x on the right side. And those x's cancel out here. And so now I've got negative 5y plus 7. sorry, negative 5y plus 7 equals 7 over x. Okay, so, I mean, this is much more straightforward than the previous problem. Here I can just subtract 7 from both sides. And I'll cancel out those 7's on the left. And that'll leave me with negative 5y equals 7 over x minus 7. And now to clear that negative 5, I'm just going to divide both sides by negative 5. But again, because I've got fractions involved, like this is like 7 over 1, right? I'm going to actually just multiply by 1 over negative 5. And that negative doesn't really matter if it's in the numerator or denominator. But I'm still going to put this whole thing in parentheses and multiply by 1 over negative 5. And all I'm really doing, pardon me, is distributing the negative 5 to the denominator, okay? So firstly, we can cancel out these negative 5's here, leaving y by itself. Y equals. So on the numerator side, things won't change. We have 7. But on the denominator, I've got negative 5x now. Okay? Negative 5x minus, or is it minus? It's not minus anymore because it's negative 5 times 1. But that's really negative, right? Negative times a negative is a positive. So that's going to be plus 7/5. Okay. Now technically we're done. You know, we did it, right? But we can maybe we can make this a little bit better by finding a common denominator. You know, between negative 5x and 5. So what I would want to do is multiply by negative x here, see? Then that would give me negative 5x. So I'd have to, but watch what I'd have to do. I'd have to multiply by negative x in the numerator and in the denominator. Because that's, you have to multiply by something that reduces to 1. So anyway, we're going to write y equals. And now I have the same denominator. Okay? So I can write 7 minus 7x all over negative 5x. Okay, and that's, I mean, we could mess with it some more, but why? You know why? So that's y to the negative first. Okay, so now let's write it in F inverse notation. F inverse x equals, and then we'll put 7 minus 7x all over negative 5x. And we're going to call it good, okay? Once I got the x's on the other side of the equation, that's kind of ugly, but I don't care. All right, now we're moving on to what looks like the boss fight. we'll see how this goes. All right, so this is number 9. And first I'm going to write this as y equals 7 plus 2x over 9 minus 5x. Okay, now let's switch the x's and the y's. So x equals 7 plus 2y over 9 minus 5y. All right, now how should we proceed? Well, we're going to have to multiply these terms together. For example, I think there's a way we could write that x over 1, right? And then we could do the butterfly thing. All right, so like this, and then like that, okay? So this is obviously the more salient issue here. This is going to be the x, open parentheses, and then I'm going to write negative 5y plus 9 just to get the variable up front, equals, and this is just 1, so I'll just write this 7 plus 2y. Okay, so at this point we're going to multiply that x through the expression there. So I'm going to have negative 5yx plus 9x equals 7 plus 2y. Okay, so now what I'm going to do is subtract 2y from both sides. And I'll have negative, well, hold on, I'm going to need more space. I'm going to have negative 5yx minus 2y plus 9x equals 7, okay? Well, now what should we do? Well, we should subtract 9x from both sides. Minus 9x. That'll clear that. Now I'm getting closer to what I wanted. I'm getting these y's kind of by themselves. So negative 5yx minus 2y equals negative 9x plus 7. Okay. Okay, so now I'm going to group these terms here, and I'm going to divide out negative 2y from both of these. And you're going to say, wait a minute, you can't divide negative 2 from negative 5. It's not going to be even. I'll just watch what happens. So we're going to divide out negative 2y from both of these, and you'll see what happens. Okay, and remember, that just pulls the terms over here. So what got canceled here? So I canceled the y's, the negative signs and this 2. Okay, so what I'm going to have left over, so over here I'll have negative 2y, right? That thing I pulled out, right? That reverse distribution. Inside it's going to get a little hairy, so let's explain. This is going to be a big 1 right here because I divided the same thing by itself. It'll be plus 1. So I'm going to have negative 2y on the outside, and then on the inside I'm going to have, because like we said, we can't really divide out 2 from 5 evenly, so we can just write 5 over 2 x plus 1. Totally legitimate. And that is equal to negative 9x plus 7. And now I'm just going to divide out this 5 over 2x deal. Plus 1. And I'm also going to divide it out on this side. 5 over 2x plus 1. We're getting there, folks. Okay, so look what happened now. I just canceled out all that stuff, and I just have negative 2y on the left. Amazing. Algebra is just an astonishing thing. Okay, so now I'm going to drop these parentheses over here. All right, negative 9x plus 7 over 5 over 2x plus 1. Okay, it's ugly, right? But it doesn't matter. And so now we're going to play the same game we played before. We're going to multiply by 1 over negative 2. The same thing here. And you'll see now why it's going to be cool, because it's going to clear this out. Just watch it. So 1 over negative 2. And now, beautifully, wonderfully, I have y by itself. And y equals negative 9x plus 7 over, and now I'm going to distribute this 2, okay? So you can, I'm distributing the 2 to the denominator, and when I distribute that 2 to 5 over 2, negative 2, to 5 over 2, the 2's will cancel. So it'll just be negative 5x minus 2. You see, because I'm distributing this negative 2, you could think of it like, forget about the top. Forget about the top and just look at the bottom. I'm multiplying negative 2 times 5 over 2. So this negative 2 over here, okay, right? When I distribute multiply, it's going to cancel with the 2 down here. So, but the negative won't cancel. So it's just going to be negative 5x, and then negative 2 times 1 is negative 2. So, lovely, lovely, we have negative 5x minus 2. And that is your y inverse. So the final step is just to write it in function notation. And let's see if we can fit it in here. I bet I can fit it in here if I sharpen my pencil. Hang on. Okay, got the pencil sharpened up. Let's see if we can write really small. You know what I can actually do is I can write it over here in this kind of open space. So I'll write down my function notation, and I can write it normal size. So that's going to be f inverse of x equals, and then negative 9x plus 7 over negative 5x minus 2. All right, and so that is what we're going to put in the red box. Okay. A hard-won battle. Okay. Oh man, that was a fun problem. It's just, you look at that math we did. Look at all that. That's so cool. Okay, so this one looks a little simpler. Number 10, 3x over x minus 1. Famous last words. This one looks easy. 30 minutes later. All right, so let's just, let's see what we'll see, huh? So step 1, let's write f of x as y. Y equals, and then I've got 3x on top over x minus 1. Okay, whatever. All right, so now replace the x and the y's. So we'll say x equals 3y over y minus 1. Okay, now what? Well, I think you know what, right? Let's do the butterfly, right? We've got this proportion, so let's multiply x times y minus 1 parenthetically like that, and then it'll be equal to 3y. Okay? So we have x, open parentheses, y minus 1, and that equals 3y. All right, well, let's gather our stuff. So let's go ahead and distribute, multiply the x to both terms inside the parenthetical expression, and simultaneously we're going to subtract 3y from both sides so that the right side is just 0 temporarily. So now I've got xy, so I'm going to make sure to put 1 xy minus x minus 3y equals 0. Well, right away I can make my life simpler by adding x to both sides, because I'm trying to get the x's on the right. So let's add x here, because that's just by itself. And at least I got one x out of the way. So now here I've got, again, I'm going to write 1xy minus 3y equals x. Okay. Well, now I bet you know what I'm going to do. I'm going to factor out a negative 3y. And you say, how do you do that? Yeah. So here's how you do it. You just do it. You know, you're the commander, so you can do whatever you want. So we're going to pull out a negative 3y. And we're going to pull out a negative 3y. Okay, so that negative 3y is going to come live over here. And what's going to cancel is the y's are going to cancel. And over here, I'm just going to have 1, right? That whole thing cancels to 1. So you'll have negative 1/3 x plus 1. So you have negative 3y on the outside. And then on the inside, you have negative 1/3 x plus 1. Okay? Equals x. So I'm going to write like that, because I'm about to make it a numerator. And now I'm just going to divide both sides by this parenthetical expression. Okay? So let's divide both sides by negative 1/3 x plus 1 on the left and on the right. Negative 1/3 x plus 1. Okay, so lo and behold, we have done it. We just have y on the negative 3y on the left. And you see, once again, when I do what I did before, I'll get rid of that fraction in the denominator over here. Because I'm going to divide, I'm going to multiply by 1 over negative 3. Okay, so I've got x over negative, I'm going to drop the parentheses, negative 1/3 x plus 1. Okay, now comes the fun part, right? The last step is to multiply both sides by 1 over negative 3. Now it's the right side that the interesting stuff is happening, and the left side is cool though because I just got y by itself. Yay! Okay. Now look what happens when I distribute this negative 3 to this negative 1/3. The negative and the 3 will both cancel, leaving x. And then the negative 3 times 1 will be negative 3. So when I'm done with this, it's just going to say x minus 3. Okay? Pretty cool. So that's some beautiful mathematics right there. And I mean, it's not my mathematics, it's just the problem. So now y equals x over, and now we're going to multiply that negative 3 through the denominator. And the negative will cancel the negative, and the 3 will cross cancel with the 3, which will just give me x, and then negative 3 times positive 1 is minus 3. So not very ugly, really. That's it. So y inverse. Okay, we can write the final form in function notation. F inverse x equals x over x minus 3. That wasn't too bad, and it's not even that ugly. So we'll put this in a box, just like this. And that brings us to the end of number 10, which is the end of the homework assignment. So I hope you found this helpful. I sure found it to be absolutely fascinating, this last page. You know, look at the math. Wow. I mean, that is so cool. And here's the math from the front page. Just awesome. Just the whole thing is super cool. So that was inverses of linear and rational functions. The rational functions were these. And I think we can all agree that these are a little bit more complex, but not hard, really. Once you get the hang of it, you know, that whole cross multiplying thing, it's just basically butterfly, but at, you know, at a much higher level. And that concludes this video. I really appreciate you watching it, and I hope it helped you learn something new in mathematics. Thanks for watching.